Hello everyone, welcome you all. So my name is Dr.R.Sakthivel Murugan, Assistant Professor in the Department of Mechanical Engineering. So today we are going to discuss one interesting topic, that is the real world examples and some case studies which is relevant to hydraulic circuits. So in fluid power automation subjects, hydraulics and pneumatics plays a very vital role for most of the industrial applications. Hydraulics deals with the circuits which works with the help of hydraulic oils. So in this sessions we are going to discuss only about the hydraulic circuits and its relevant real world examples, because in the previous classes we have already discussed about various applications of hydraulic circuits, what are the components of hydraulic circuits, and how to design a hydraulic circuits, that we have already discussed. In this class we are going to discuss about some common real world examples where these hydraulic circuits are applied. So let's discuss one by one. So in this video we are going to discuss about the following real world example. The first one is drilling machine, that is the drilling machine with the aid of hydraulic circuits. It is known as drilling circuits. So mostly the hydraulic oil which is used as a fluid medium for making the automation of this drilling process, that is this hydraulic circuits usage. The first one is drilling, the next one is planing, that is hydraulic oil which is used in planer, and next one is shaping machine, that is the shaping circuits, that is the hydraulic oil which is used in the hydraulic shaping. Then the surface grinding machines which is associated with this hydraulic oils, then the punch press applications, and last we are going to discuss about the forklift applications. So these are the examples that we are going to discuss. So let us explain one by one in this video. Now the first we are going to discuss about the first circuit, that is drilling machine circuits. So this is a manual drilling machines. So in drilling machines, first what we are going to do is, here you are going to apply a tool, so where the drillings would be applied. So the drilling is applied in this vertical Z direction, this is minus Z direction, and before this we need a cylinder for clamping. So for clamping we need a cylinder 1, and for actuating this head we need a cylinder 2. So totally 2 cylinders is needed for making automation of this particular drilling machine in a sequential order. That's why we are using a sequential circuits in this drilling machines. So in the earlier discussions we have made how the sequencing circuits have been run and what are the components for this sequencing circuits. So for constructing a sequencing circuits we need an electrical motor associated with the hydraulic pump, a pressure relief valve, and here are the sequence valves. This is sequence valve 1 and this is sequence valve 2. These two sequence valve is associated with check valves. So this is a common sequential valve circuits. So this circuit is applied in a drilling machines. How? So here it is consists of one cylinder 1 which is used for movable jaw. This jaw is used for clamping and unclamping the workpiece. So this is the cylinder 1. The cylinder 1 is attached here. So this one is moving for clamping. So that's why it is also known as clamping cylinder. And it is another cylinder, that is cylinder 2. This cylinder 2, here you are having a drill pit which is associated with an electrical motor. So in this cylinder 2 only we are going to engage this entire electric motor along with this drill pit. If you apply downwards, then automatically the drill pit will be moved downwards and after completing the work the drill pit moved upwards. So this is what the operations of this particular hydraulic drilling machines. So here if you look at, it will operate in a proper sequence. So here first we need a clamping of this device. After clamping we have to apply the drilling operations. So if you consider this C1 and C2, this is A cylinder and this is B cylinder, then what will be the sequence is, first the A cylinder should be extended. So A plus should be done first. After extension of this A plus, this clamping has been completed successfully. After the clamping only, then we have to apply the drilling operations by moving downward this entire setup. So then only we have to move this B cylinder downwards, that is extension. Once after the drilling process has been completed, then we have to return back this cylinder first, because after putting the drilling process, the cylinder should be moved upwards again. So therefore, B should be retracted first, and the last only again this clamping should be retraction for unclamping operations. So this is the sequence that is needed for this particular application, that is drilling of an equipment components. So for this, how will you circuit the pump which is associated with, this is a 4/3 DCV valve. So this 4/3 DCV valve is directly connected to two cylinders through this sequence valves. So for example, first if you want to clamp the cylinders, so this entire operations is connected with this clamp one. So here the fluid passes from this to this and its work, and therefore the cylinder extended. Based on this extension, here some back pressures will be generated. Based on this back pressure, the circuit is connected with the sequence valve. Once if the further pressure has been associated, because here we have to set the pressure value, once if a high pressure has been attained due to the complete extension, then the sequence valve will make the flow from this place to this cylinder. So once after the A plus has been extended, then the cylinder B is extended. So this is what the first one. This is for grouping of one, and this is for next grouping. So for first grouping, this is for first grouping, and this is for second grouping. If you actuated the lever, the group 1 is extended. So if you again pull back the lever back, so then the group 2 is actuated. Once the group 2 is actuated, here the fluid supply is run to this cylinder B, therefore the B minus is actuated. Once if there is a back pressure is created, here you are having a sequence valve circuits. After the sequence valve is extended, here this A cylinder is again returned back. This will be moved to and fro simultaneously. So this is proper a sequence valve circuit connection is there, because we have already discussed. Now this entire sequence circuits is applied in this drilling machines, that is extension of clamping cylinder first, then applying of this drilling operations by making this electrical motor along with drill bit making this extension second, and afterwards by altering the lever position back to the original state, again the drill bit moved upwards, followed by the retraction of these cylinders. This is what the real world examples of one of the usage of hydraulic oils which is applied in hydraulic circuits. So then similarly we are going to discuss about the shaping machines. So in this shaping machines, so if you look at this, so here it is a normal shaping machine circuits, and here it is another circuits which is used for some specific operations. So in this circuits, so this is a pump. The pump is associated with the cylinders, and here it operates, and here this is the pump. If the fluid is traveling from this pump, it moves from this place to this place, and it makes the cylinder to extend in this direction. This makes the ram to moving in this plus direction first. Once the position has been activated, again the fluid supply is back to the back positions. So here to erase this, and we are going to apply the fluid from this place, and here the fluid is transferred to this rod end of this particular ram. So here again the ram is moving backwards. This is what the normal operation of a hydraulic shaping machines based on this circuits. Now in this circuit, what is the drawback is we can't able to control the speed of the shaping machines. In a shaping machine, what is the main objective is, while applying here, this is a workpiece is be there for making the material removal process. For the material removal process, the ram should be moved in a very slow manner. Then only we could able to make the entire machining process in a very effective manner. If both the forward stroke and the return strokes in the same speed means, we will not make the tool cutting effectively, and also if we reduce the speed of the retraction, that is at the return stroke, in a very slow manner means, then the machining time will be increased. So to make the machining time in a very reduced manner, to make the high productivity contents, so we need to operate the entire shaping machine in one stroke in a very fast manner, one stroke in a very, that is extend stroke in a slow manner, and while returning back it needs to be a very fast speed. So therefore for this we are recommending this circuits. What is the name of this circuits is, here you are having one throttling valve. So the throttling valve is applied at the rod end of this particular ram. So that's why this concept is known as meter out circuit. hydraulic circuits. The same meter out hydraulic circuits is applied in this particular shaping machine. So if you look at this, as usual, the cylinder associated with the pumps is applied to, that is a solenoid operator 4x2 valve. So if the solenoid is operated, so here the fluid will be flowed from this direction through a throttle valve setup. So in this throttle valve, here you are having the high flow rate. So after exhausting one, here if you released this check valve will be released back. So therefore this flow rate, so if you applied the flow rate Q1, the same Q1 will be passed through here. That's why if the flow rate is same due to the application of this check valve, the fluid from this port to this port in a very fast manner. So therefore the return of this ram is acquired in a very fast manner. And similarly, if you applied the position, if you change the, so if you operated the solenoid in this, so here the fluid will be transferred here. Here now, if you apply this fluid, the excess fluid in this area will return back from here to here. So here the check valve is blocked. So the only possible way to make the fluid is through this throttle valve. So here you are having the high flow rate, and through this throttle valve the flow rate is reduced. Therefore here the flow variations will be there. So due to this flow rate variations, that is Q1 is larger than Q2, based on this difference in the flow rate, the speed of the entire ram is reduced. Therefore the extension of the ram is in slow manner, and while return it is in fast manner. That's what the usage of this meter out circuit. It is applied in this particular shaping machines for further use. So this is the use of this particular shaping machine, that is the use of hydraulic circuits for the shaping machine operation. That is, they are using this meter out circuits for this shaping machine working. And then we are going to discuss about the surface grinding operations. So you know the surface grinding. So here you are having one limit switches. This is a limit switch and this is another limit switch. So it is actuated by the roller. So here also we are going to make this lever actuations by using this pilot operated hydraulic valves. So once if the table is moving this side in to and fro directions, so this end of the table is touches. For example, here you are having one rod and here you are having one rod. If these two gets contacted, then this pilot connection is again touches here, and the again fluid passes from this direction. So once if you touch the roller in this direction, the table automatically moves back to this particular state, and once again if these two rollers are getting in contact with each other, then this table is moves in this direction. So automatically these two oscillations happened simultaneously, that is based on this contact of this particular pilot valve. So due to this, the effective grinding operations on the workpiece has been made. This is what, based on this, the automations, usually in surface grinding machines, operators should be standing here and they are giving the feed manually, but due to this operations the feed is given automatically by using these types of application of this hydraulic operated valve. So that is the use of this surface grinding machines which is associated with this hydraulic oil. And this is one which is punch press applications, and here this is a pressure intensifier. So here a pressure intensifier is used along with the single acting cylinders. So here a punch is applied. So what is the working of this punch press application is, once if the cylinder is applied to the port A with a pressure 1, so the cylinder is gradually increased up to this end. So it actuates in a slower manner with some accent. So after time it is used for just clamping. So the clamping operation has been completed with the pressure 1 of this particular pump. So then the excess fluid, because here if the pressure is actuated in this pressure P1, so here the fluid is compressed. So here pressure 2 will be activated, because at first initially if the piston is in this position, the cylinder position will be there. Once if this area is come to contact with this, then the pressure P2 actuated. Once if the pressure P2 actuated, then this punching operation is done. So pressure P2 is used for punching operations. So in a very only a pump with the same pressure, a single pressure is delivered by a fixed pressure is delivered by a pump. So, using this pressure intensifier, it will be converted to two varying pressures P1 and P2. So, if you look at this, the diameter is reduced to half. So, therefore, P2 is twice more than that of the P1. So, P1 pressure is required only for clamping the workpiece, and the P2 pressure, that is twice that of the P1, which is used for making the punching operations using the same pressure of a single pump. Or else what happens, we need two pumps for actuating this entire punch press applications, one for holding and another for punching operations, which needs a high cost. So, in order to reduce the cost and to make the circuit in a very simplicity manner, so we have to include this pressure interface device for making the clamping and punching operations in a single circuit, that is the punching circuits, which is applied for this punch press hydraulic circuit components. The last one is this forklift applications, which is very essential in most of the industrial circuits. So, here the forklift applications has been made. So, this is a forklift which is having the major components of tilt cylinder and lift cylinder. This lift cylinder is used for making this entire portions is moving up and down, and this tilt cylinder is used for making this angle theta. So, just for making this tilting is depends upon this angle theta is also equal to this theta. So, this is the purpose of this tilt angle. So, the tilt angle is controlled by using this hydraulic cylinder. Again, here the lift cylinder is controlled by this cylinder. This cylinder in red color is used for lift cylinders, and this blue color cylinder is used for tilting. Based on the extension stroke, the tilting angle has been controlled. So, this is what the hydraulic circuit which is drawn and has been successfully we have completed using a simulation softwares. I will explain the circuit in the next slide, and this is what the circuit used in that forklift operations. So, here we are having the two lift cylinders and the two tilting cylinders. So, two lift cylinders are used and two tilting cylinders are used. All these cylinders are controlled by using this 5/3 valve. These are all 5/3 DCVs, which is operated by lever. These are all the lever actuated 5/3 DCV valves. Okay. Once if it is controlled, here also we have additionally have a steering cylinders. The steering cylinder is completely won by using servo valve. So, this is a servo valve. This servo valve is actuated based on the steering rotation. If the steering is rotated right, this valve is actuated to and fro. Based on this feedback, the forklift should be moved to make the forklift to turn on the right side or left side, as like the automobile just works. So, for steering this entire forklift to turn right or left direction, we are using this particular circuit systems by using a that is a double actuated cylinders along with the servo valve. And for making the lift cylinder up and down and the tilt cylinder, we are using this 5/3 DCV valves just to control the working operation of a forklift applications in an industrial use. So, in this videos we have discussed a lot about the hydraulic circuits, and those hydraulic circuits is applicable to some practical industrial applications. While using these hydraulic circuits along with this practical applications, we made that entire application should be work in a more effective manner. So, based on this, the hydraulic circuits is effectively integrated with this industrial machineries to make this entire fluid power automation systems to make the industrial setup in a very effective manner. So, thus these types of the automation process along with the assistance of this fluid power, that is the hydraulic power, to make the entire industries to work with a more effective and efficient manner, and thus it supports the industry 4.0. So, thank you for your support. Thank you.